sklearnutilsresample. Description. The resample function from scikit-learn's utils module provides a convenient way to perform various resampling techniques on data, enabling tasks like bootstrapping, subsampling, and creating balanced datasets. Inputs. Array: the input array or sequence containing the data to be resampled. It can be a 1D array, a 2D array representing samples as rows and features as columns, or a list of arrays. Replace: a Boolean value indicating whether to sample with replacement. If true, the same element can be selected multiple times. If false, each element can be selected only once. N samples: the desired number of samples to be drawn from the input data. Random state: an integer value or none. It specifies the random number generator seed for reproducibility. If none, the random number generator is initialized with the current system time. Stratify: an array-like object containing the labels or group identifiers for stratified sampling. If provided, the function ensures that the proportions of each group in the resampled data remain consistent with the original data. Outputs. Array: the resampled array with the specified number of samples n samples. The shape of the output array depends on the shape of the input array. Steps. The function first initializes a random number generator based on the random state parameter. If stratify is provided, it performs stratified sampling, ensuring that the proportions of each group are preserved in the resampled data. The function then draws samples from the input array based on the replace and n samples parameters. If replace is true, samples are drawn with replacement, allowing the same element to be selected multiple times. If replace is false, samples are drawn without replacement, ensuring that each element is selected at most once. Metrics. The effectiveness of resampling techniques is typically evaluated based on the performance of subsequent models trained on the resampled data. Common metrics include accuracy: the percentage of correctly classified samples; precision: the proportion of positive predictions that are actually positive; recall: the proportion of actual positive cases that are correctly identified. F1 score: the harmonic mean of precision and recall. Visualization plots. Scatter plots can be used to visualize the distribution of data before and after resampling, particularly when dealing with two-dimensional data. Histograms can be helpful to visualize the distribution of features in the original and resampled datasets. Fine-tune parameters. Replace: adjusting the value of replace allows you to control whether to perform sampling with or without replacement. This can impact the variance of the resampled data. N samples: the n samples parameter determines the size of the resampled dataset. Varying this parameter allows you to create datasets of different sizes. Stratify: the stratify parameter enables stratified sampling, which is crucial when working with imbalanced datasets or when you want to preserve the proportions of different groups in the resampled data. Uncertainty methods. Bootstrap aggregating bagging is a common uncertainty estimation technique that uses multiple resampled datasets to create an ensemble of models. The variance of the ensemble predictions provides an estimate of the model's uncertainty. Challenges and fixes. Challenge 1: imbalanced datasets. When working with datasets where certain classes are significantly underrepresented, resampling techniques like oversampling or undersampling can be used to create a more balanced dataset. Sample use case that resulted in Challenge 1: a dataset with 90 samples belonging to class A and 10 belonging to class B. Fixes to Challenge 1. Oversampling: replicate the minority class samples class B to create a balanced dataset. Endosampling removes samples from the majority class A to achieve a balanced representation. Challenge 2. Overfitting. Resampling can sometimes lead to overfitting, especially when using techniques like oversampling. Overfitting occurs when the model learns the training data too well and fails to generalize to new data. Sample use case that resulted in challenge 2. A model trained on an oversampled dataset might perform exceptionally well on the training data but poorly on unseen data. Fixes to challenge 2. Regularization techniques. Use regularization techniques e.g. L1 or L2 regularization to prevent overfitting by penalizing complex models. Cross-validation. Perform cross-validation to evaluate the model's performance on unseen data and identify potential overfitting. Challenge 3. Bias in resampling. Resampling methods can introduce bias if not used carefully. For example, random endosampling might remove important information from the dataset. Sample use case that resulted in challenge 3. Randomly endosampling a dataset might remove important samples that are crucial for the model's learning. Fixes to challenge 3. Stratified sampling. Use stratified sampling to ensure that the proportions of different groups in the resampled dataset are representative of the original data. Adaptive resampling techniques. Explore adaptive resampling techniques that adjust the sampling process based on the characteristics of the data.